Hello again, everyone, and welcome back to your channel of Math and Engineering Made Easy. We are still in the process of trying to understand vector fields, line integrals in vector fields. We had a couple of examples before. Today, I want to introduce a third example because the way the problem may be presented to you would be slightly different. So in this case, they give us an example. They say, let's assume the force you have is yz uh, dx plus xz dy plus xy dz. Okay? So you say, what? Why do I have dx, dy, dz? Yeah, that's the way they present the force. So when we do the dot with r or dr, notice that dr can be written as dx dt times dt plus dy dt times dt plus dz dt times dt. So now that simplifies things for me in a way, right? Let's write first the position vector, or r of t, is given to you as 1 minus 2ti. And again, since here I made that a vector, I didn't put it, I would have to say I, j, and k also. Or write it differently, plus 1 plus t j plus 1 minus tk. And we tell you that t goes from 0 to 1. Just make it easy. What is the word? What is f dot r or dot dr? The integral of that. As we've done before, we are going to get the dr dt, and dr dt here can be written as dx dt plus dy dt plus dz dt times dt. So basically what we are going to write here is simply negative 2i plus j minus k, right? That's the thing. And then when I do my integral, it would be the integral from 0 to 1, the line integral. I'm going to multiply y times z. Notice that's easy. 1 plus t times 1 minus t is 1 minus t squared. So 1 minus t squared dx, which is negative 2. And the I dot I would cancel. So that's the dot product. I multiplied the y times the z times the negative 2, which is the dx. But I wrote it as dx dt, right? And then I'm going to multiply at the end of the day, I would multiply by dt. Okay. Second, so I'm going to multiply this by that times 1. So plus the 1 is just multiplied. So I will get 2t squared minus 3t plus 1. That's in the j direction. And then finally in the k, you're going to multiply x by y and then change their sign. So it's easy to say, well, x times y is negative 2t squared, but I'm going to write it 2t squared because it's of the negative. And then I have negative 2t plus t is negative t, so plus t. And finally 1, I'm going to write it minus 1 dt. Okay? So when we simplify that, negative 2 times negative t squared is positive 2t squared plus 2t squared plus 2t squared ends up with as 6t squared. Then for there is no t's here. I have negative 3 plus 1 is negative 2t. And then for the constants, I have negative 2 plus 1 is negative 1 minus 1 is negative 2 dt. Very simple. Finally, I evaluate the integral. So 6t squared will be 6t cubed over 3 or 2t cubed. The negative 2t, the t squared over 2, the 2's cancel and I get negative t squared. And then the negative 2 becomes negative 2t. Again, for simplicity, I'm not going to evaluate the 0, of course. So I have just, remember when I told you in the first session, if you end up with a polynomial, you only are adding the coefficients. So I get 2 minus 1 minus 2. The 2 and the negative 2, of course, cancel. And you get the answer is negative 1. Meaning the motion eventually is opposite to the force. The negative sign is telling you that the work done is negative, right? Like gravitational force produce negative friction force produce negative work and so on and so forth. I think that concludes this topic of line integrals in vector fields. I hope it was easy for you to apply. And next time we are going to go a step further and see how we can perform this thing slightly differently and what do we mean when we discuss the conservative vector fields, and that would lead us later to Green's theorem and Stokes' theorem that make a lot of simplification, as you will see in integrals. And that's it for today. I wish you had an easy explanation here. If you have any comments or if I did any mistake, as I usually do, you can send me a comment in the comment section, and I will get back to you as soon as I can. Otherwise, wish you all the best and hope to see you soon.